My goal here today is to help provide an overview of SOLIDWORKS Inspection and clearly illustrate the advantage that this software tool gives you in streamlining your quality inspection process. If you or someone you know or someone who works for you is responsible for generating inspection reports, it makes sense that you're tuning in today, because my goal is to show you how SOLIDWORKS Inspection can make your life easier through streamlining and automating the process of generating inspection documents. I'm not a great big PowerPoint guy, so we're going to just jump right into the software here, and I'll talk about it while we're working with it. So, creating inspection documents. You may have internal inspection procedures, or you may be following standards-based inspection procedures, first article inspection, maybe inspection regimes governed by AS 9102. You may be doing PPAP, in-process inspections. What is common across all of these different inspection types and regimes is that generally the process of creating your inspection documents can be a little tedious. In my opinion, probably the majority of folks who create inspection documents follow a process that usually involves a scripto Sharpie pen. And you take that Sharpie pen and you create balloons on your paper drawing, and then you have to synchronize and coordinate your inspection characteristics, the balloons, with a specific row on an inspection sheet. It's a somewhat tedious process fraught with errors. What you're going to see here today is how there's a software tool from SOLIDWORKS Corporation that can automate that process. First, a little history. SOLIDWORKS Inspection is the brainchild of a gentleman named Jeff Cope. He actually used to be an applications engineer for Trimec Solutions. And in 2007, he struck out on his own and started a company called Extensible CAD. Jeff had a wide experience with inspection and quality, and he realized that there were no good inspection tools out there that can help generate inspection documents. So he programmed and created a software tool called Inspection Expert. There were various flavors of Inspection Expert. There were plugins into the major CAD systems, including SOLIDWORKS, as well as a standalone Inspection Expert tool that helps automate the process of creating inspection documents from PDFs or TIFF files. In January of 2014, SOLIDWORKS Corporation bought Inspection Expert and a lot of the other intellectual property that Jeff had created, and gave it their branding and the benefit of their development team. So you may have worked with Inspection Expert in the past. It was a gold partner to SOLIDWORKS, totally integrated within the SOLIDWORKS environment. And now, a couple years past, we've seen some improvements in the software tool, more than just the rebranding of the name. I want to talk about SOLIDWORKS Inspection. I want to start our conversation, say, at 80,000 feet. When you get SOLIDWORKS Inspection, you're actually getting two flavors of that software tool, and I'll show you both today. The first flavor of that software tool is called the add-in. It's an integrated package within SOLIDWORKS that allows you to work on your native SOLIDWORKS drawings. We're also going to take a look at the standalone application, because not everybody has SOLIDWORKS or a CAD tool. Sometimes we have to inspect to that PDF file that our customer or our vendor has sent us. And the standalone inspection, SOLIDWORKS Inspection tool will also allow you to automate and streamline the process of ballooning and generating inspection reports synchronized with those characteristic numbers on the balloons. Finally, the standalone version of SOLIDWORKS Inspection also has a bundle level called Inspection Professional that allows you to import your measured inspection data and even pull in some CMM reports. We'll talk about that at the end. But to start the demonstration here today, we're going to be working within the add-in version of SOLIDWORKS Inspection. You simply go to your add-ins, and when you have SOLIDWORKS Inspection, you activate the correct add-in from your add-in dialog, and this is what you get. In your drawings environment, you get a Command Manager tab, complete with 12 buttons. You get a tab in the left pane of SOLIDWORKS that duplicates a lot of that functionality, and we work with our inspection characteristics primarily through the left pane here. And we also get off of our tools pull-down menu, you notice we get a pull-down menu as well that mimics the buttons that we have on our toolbar. It doesn't seem like you get a lot, but I think of SOLIDWORKS Inspection as an app. It doesn't do a whole lot, but what it does extremely well. So don't let the minimal interface design fool you. It's an extremely powerful tool. We're going to start an inspection project. And again, I'm going to work almost exclusively within the left pane of SOLIDWORKS. And to initiate an inspection project, you can just click on the toolbar button and in various locations. And the property manager here in the left pane is prompting us to select a project template. It's pretty cool that SOLIDWORKS allows you to use templates to preserve the kind of information that might be relevant for a specific inspection regime. You may have certain inspection regimes for different types of manufacturing techniques. The tolerances on a forged part are certainly going to be different than a tolerance on a machine part. You may have to follow an inspection regime based off of a statistical value, say through your AQL, your acceptable quality limit. So you may want to preserve the settings that you have for any inspection project as a template. Finally, you may want to preserve or create project templates for certain customers, because certain customers' inspection regimes are going to be different than others. They may or may not be based on statistical standards, but you certainly always do have to appease your customer. The promise of everything computing is that you create it once and copy it forever, and SOLIDWORKS Inspection is no different, in that once we set up the parameters for the inspection regime here, we'll be able to save all of those as a template, so we don't have to go through those gyrations again and again. We're going to use this default template because I do want to show you how we create the parameters of our inspection regime, and I'm just going to accept that, and what it does is it throws us into this General Settings tab. I want you to notice that we're in a wizard. If you've ever installed a piece of software and clicked on the Next button, you have worked within a wizard, and I want you to notice that we do have a Next button right here in our Property Manager. So the first thing we need to do is define some of the information associated with this inspection project, things like the part name, the part number. Any of the information we put in here will be propagated, or rather has the potential to be propagated over to the inspection report. Again, fingers have to hit the keyboard at least once to populate information, and ideally it should only be once. So as far as the part number associated with this inspection project, I could certainly key it in, but the add-in is also aware of SOLIDWORKS custom properties. Notice when I click on this part number button, I get this dialog where I can extract the custom property information from the drawing I'm currently working in. We could also extract custom property information from the model whose drawing views are visible in this drawing, and even configuration-specific custom property information. So in our case here, for the part number, I'm just going to grab the part number item here, and it's going to pull that information over from SOLIDWORKS custom properties. The part name is a sensor housing. We can grab a revision from our custom properties. Again, I can type this stuff in if I wish, and just to show you, we can even extract this information from the model itself. We can type this in, inspection, doc. We have a vendor pull down here. This is hard-coded. You don't have to use this particular field for vendors. It might be customers. It might be machine names, various machining center names. You can certainly use this to your advantage. Again, this is a piece of metadata information that has the potential to populate your inspection report. And we'll put a job number in here as well, ABC 123. Now, When we tell SolidWorks Inspection to create some inspection characteristics for us, we get to tell it what number to start at and what direction to do the scan on this SolidWorks drawing. And we're going to start at characteristic number 1, and then we'll do a counterclockwise scan. And we're going to set the classification, the overall default classification for all of our characteristics to the value that we want it to be most of the time. This default classification will be assigned to each extracted characteristic. You want to select the classification type that is most prevalent in your current project. Again, take a wholesale approach, set them all to major, and if that's the majority of the classifications in this document, and if certain of them are critical and others are incidental, I will change them as required. Also, we are going to get the opportunity to create a characteristic for each instance of a particular dimension in our drawing as well. And finally, we're going to tell SolidWorks Inspection to balloon out our drawing also. Now, there's some pretty robust statistical tools under the hood in SolidWorks Inspection. We can use acceptable quality limit statistical analysis. We can tell it the lot size, the default inspection level, whether it's close, normal, or tightened inspection regime, and finally our quality level. And again, these are well documented as well. We're going to say a 2.5 acceptable quality level here. Once you fill out this information, you simply click on the next button to proceed to the next sheet in this wizard. And now we get to tell Inspection what information in our drawing we want it to consider and to create inspection characteristics, inspection items for us. We want to take a wholesale approach. What we do here is we specify categories of information, categories of annotations in our drawing that we wish Inspection to extract the information. The approach here and the overarching logic is that you create a set of items that you wish to extract the information from that is greater than all of those items. In other words, you're going to end up with more characteristics than you initially need, and then you simply tell SolidWorks Inspection that you don't want to inspect specific items. So we take a wholesale approach and we remove the outliers. So in this case, we wanted to include dimensions. We wanted to include any reference dimensions as well. To consider secondary units, whether or not it should consider dimensions with overridden values. We can extract characteristic information from any notes that are in our drawing, and we even have the option to extract them from the sheet format. This extraction criteria has a standard expression which can help you filter the kind of notes and information that this extraction routine will consider. In my case, I'm just going to clear this right now. It's somewhat irrelevant because it's not going to be grabbing any notes either. We also wanted to include geometric tolerancing symbols, any hole callouts, any weld symbols that appear in here, as well as any surface finish symbols. Again, the objective here is you specify some criteria that give you more characteristics than you need, and then you can simply turn off the ones that you don't need, this wholesale approach. We're going to click on Next here, and now we get to set up our tolerance settings. So what we do in this sheet is we get to specify, in essence, the block tolerances that are applicable in this inspection regime. In fact, we can zoom in on our title block here, and you can see that we have some block tolerances. We can specify that the tolerance value to be used for dimensions that do not have explicit tolerances are going to follow the settings that we have in here. So we can see that for 1 decimal place, we would want our values here to be 50 thou plus or minus. Again, these are the kinds of items that can be saved in an inspection project template. 2 decimal places we'll say is a 20 thou tolerance, plus or minus. 3 decimal places we'll stay at 5 thou. And I don't have any 4-place decimals in here, so I'm simply going to set those to 0. This is not the only way that you can specify your tolerance settings. You notice that we also have an option here to specify our tolerance settings by range. This can be helpful, for example, if you follow a tolerancing regime there where you have a specific tolerance, maybe from a 0 to a 1/4 inch, you're only permitted to have a 5 thou plus or minus, but from a 1/4 inch to 1 inch, you might be okay with 10 thou plus or minus. So that's another approach, another piece of logic you could use to specify your tolerance settings. Or finally, you could just tell it to use whatever the document defaults are for those tolerance settings. We also have the opportunity to specify tolerance settings for linear as well as angular dimensions. Again, this is the kind of stuff that we would want to have preserved within our project templates, and we'll do that here in just a moment. But at this point, I'm about to hit the green OK button. And if I was doing a live demonstration, I usually make a funny comment about nobody should blink or else they're going to miss all the good stuff. Because when I hit OK here, SOLIDWORKS Inspection scans our drawing, takes note of all of the dimensions and annotations that I told it to look at, and just like that, it has ballooned out our drawing for us. The folks who use Sharpie are going to love this one. So take a look at what we got here. We have a number of inspection balloons that have showed up. They are associated explicitly with certain dimensions. So if I pick on this dimension here, this 0.307, you notice it shows us that it's characteristic number 1, hence the number 1 balloon. And based off our block tolerances, it knows that a 3-place decimal is plus or minus 5 thou. It calculates the upper and lower limit for us. And it gives us additional information in here. Any of the information that we put in these property fields, whether it's information extracted from the drawing or information that we type in ourselves or use in a drop-down, that will show up or has the potential to show up in our inspection document. We can say what kind of operation is used in the creation of this particular feature that this dimension represents. Notice also if I click on this GD and T symbol, it knows the value of it and the subtype, and it also knows our limit here as well. Also notice that the acceptable quality limit, whenever we pick on any one of these items, is being calculated for us. So with an AQL of 2.5 with a lot of 200, you have to do a sample size of 32, and you can accept the lot if you have 2 that are out of spec, but you must reject the lot if you have 3 that are out of spec. Again, these are common, well-known AQL standards. The balloons, by default, are not attached to the characteristics, but you have an option to do that. We'll talk about that here in a bit. Various dimensions that, for example, that aren't important to us. This is clearly a reference dimension, this 1.296. But in my extraction parameters, I told it to look for inspection dimensions as well. Or excuse me, and if I want to, I can say, you know what, this reference dimension, I take that back, the reference dimension, I really don't want a balloon for it. So what I can do is simply tell inspection that I don't wish to have a characteristic created for it, remove the check mark here, and inspection re-balloons the entire drawing, removing the one that we didn't want. So this is how we can execute on removing those items that aren't important to us. I want to point out that those block tolerances that I applied are relevant only for dimensions that do not have explicit tolerances. This length dimension, for example, this 1.901, has explicit tolerances of +2 and -1 thou. And notice that SOLIDWORKS Inspection recognizes those and applies it correctly. It's only on those dimensions that do not have block tolerances, that don't have an explicit tolerance, rather, that those block tolerances are applied. Let's take a look at a few more dimensions here. This 800 thou dimension, for example. Maybe this is a critical dimension. Maybe you want this classification of this dimension to be as shown as such. In fact, we can even up the ante here and say not only is this a critical dimension, it is a key dimension. Look what happens when I activate the checkbox to say that this particular dimension is a key dimension. It has changed the flag, or the balloon for us, and flagged it for us to indicate that is a key dimension. This particular dimension as well, how are we going to measure this? maybe we're going to use gauge blocks. How about digital calipers? And, maybe there's a note in here that, take finish into account. Again, our goal and our job here is to provide as much information as we possibly can that will be migrated over to the inspection report that will be part of the end result of this. If we create new dimensions, we would always have an opportunity to update the project with any document changes. If any geometry changes occur as well. Let's take a look at some of the other options we have in here. In the drop-down lists, we had a number of inspection methods that we could use. We can add our own to this list. We can also, as I said, edit various operations. If you do turning in your environment, you say, let's just add turning. And now this will be available in any inspection characteristic drop-downs here. And finally, we can edit our vendors. Again, you don't have to use this for vendors. You can use it for customers or machines or any other item that you'd like to parse out with respect to your inspection regime. Again, I think we can all see here that ballooning this guy out was really easy. It was just the push of a button. But that's only half the job. The other part, the other half of this job, is creating the inspection report. And while we may have saved ourselves a tremendous amount of time simply not using a Sharpie by automatically ballooning this out, the second half of this is creating an Excel-based inspection report that synchronizes and coordinates our balloons with the item numbers in each given row in our inspection report. To create that inspection report, again, is just a push of a button. What this uses are Excel templates, and I'll show you at the end here how you can set up an Excel template so that it will work nicely with SOLIDWORKS Inspection. To create an inspection report, we can simply click on this button, Export to Excel, and we're offered an option to select a specific template. We have a couple out-of-the-box templates. I've created a template that we can use here, maybe appropriate for an in-process inspection, somewhat of a more generic inspection, but I'll show you a first article sheet as well here. And now we've added this somewhat generic detail inspection document template. We can use that, and again, nobody blink. When I hit OK here, the software extracts the metadata associated with each of the balloons, with each of our item numbers, and we get our inspection report like so. I want you to notice a couple things. In the inspection report, the item number, the part number propagated over, as well as did some information regarding a project. This was brought over from our SOLIDWORKS custom properties. Notice how inspection does a great job of doing the capture on our geometric tolerancing symbols, and it shows us the nominal value, the units, upper and lower limits. I do want to point out you could also specify your tolerance ranges. What you're seeing here in this document is just one execution of the kind of information that might be important in here. Again, I'll show you in just a moment how you can specify what information shows up in your documents. Notice for that particular dimension, number 22, that 800 thou dimension. Well, back here in SOLIDWORKS, that 800 thou dimension, of course, is number 22, and they're simply synchronized with one another. And we could also have this flagged, if we wish, as a key dimension. Again, it's up to us what we choose to show in each column in here. So again, pretty easy to create this. And if you do make some changes, it's really a simple matter of, let me throw this out on my desktop. If we make some changes, it would be a simple matter of re-ballooning this guy and then re-exporting that information out. Now, if we have to pass this along to somebody else in our QA/QC department and they don't have SOLIDWORKS, they need a PDF of this to accompany it. And exporting this drawing that's all ballooned out to PDF, again, is a single push of a button. We click on this guy, generate a PDF as required, and now we can send someone our entire drawing package consisting of the PDF and the inspection document, and it's ready to go. How much time have you saved by doing something like this? The folks at Scripto are running scared. You know, those are the ones who make the Sharpies. I'm going to pause here for a moment because this is the overview of the add-in to SOLIDWORKS. I'm going to take a quick pause, give you an opportunity to ask any questions that you may wish, and then we'll proceed on with the standalone application. So go ahead and type in if you have any questions. All right then. I must be doing a fantastic job. You guys are wowed into silence by the waves of awesomeness coming off of your computer. The other flavor, the other half, the other application that comes with your SOLIDWORKS inspection license is a standalone application. I'm going to close SOLIDWORKS down. You know, we're not always presented with SOLIDWORKS drawings. Sometimes we're given drawings that are PDFs or worse, scans, maybe a TIFF of a sepia that's 50 years old, but we still need to inspect to those documents. They are the single version of the truth to which our customers are going to hold us before they pay us. So SOLIDWORKS Inspection, the other flavor is this standalone application. And I'm going to launch this guy. And while that's launching, I want you to, I got to talk about a few nuanced differences between the add-in version of SOLIDWORKS Inspection and the standalone version. If the overarching philosophy and logic in the add-in version of SOLIDWORKS Inspection that we just saw is that you take a wholesale approach, you pick more than what you're interested in and you remove what you're not, the logic in the standalone application is opposite that. We take a more measured, incremental approach to selecting the dimensions, symbols, annotations, etc. that we wish to inspect to. This process is dictated by the fact that a TIFF or a PDF is pretty much a dumb document. You know, even the text in a PDF file doesn't know that it's text. So SOLIDWORKS Inspection Standalone uses optical character recognition. It uses OCR to take a look at the text on your TIFF or PDF file, and using the magic of a computer, it can determine what kind of text you're looking at. So we generate our characteristic list one item at a time in the standalone application. And again, it is certainly a order of magnitude faster than using a Sharpie. Let's take a look at how this works in the standalone application. Again, we have the benefit of templates. We can migrate our templates from the standalone application to the add-in and vice versa. We're going to create a new inspection project. And notice that we have these project templates. And again, any of the items that I'll show you as far as your block tolerances and such, those are saved in your templates. And the very next thing that the standalone application asks us to do is to select a drawing file. Notice the file types available to us. We can grab a PDF or a TIFF file. And even if you grab a TIFF, it automatically converts it into a PDF. So I'm going to navigate my way to the appropriate location here, and I'm going to grab this PDF of a machine part. We're going to let it open that guy up. And then the process you'll see here is similar to what we did in the add-in. We can provide some information here regarding the part name, the part number, revision, etc. We can't extract metadata from this file, but there's something that's almost as good. We can use optical character recognition. Before I do that, I want to show you where we set the options. So I'm going to go in to our inspection standalone options, and there are certain options that are application-wide. There are other options that are project options, and that's what we want to take a look at here. Because under our general project options, you see here that we have pretty robust capabilities to create, to specify the unit system in use in this document, and even it parses it out to specific unit systems for various geometric tolerance types, circularities, parallelism, etc. Here we get to specify either by precision or range the block tolerances for this particular document. So we might say, we might set it to the way we had it before with 1 decimal place. Maybe it's a 50 thou tolerance. And with 2 decimal places, it's a 20 thou tolerance. And with 3 decimal places, it's a 5 thou tolerance. Any of the other project options that we set here, not every PDF file is going to look as nice and clean as the one on your screen. So there are options we have here with regard to the sharpness and some of the characteristics of the OCR. We can also set default settings for the balloons that are going to populate our PDF, the color, the border color, the size of the text, etc. And we have a bunch of options we can use as well here when we export our balloon drawing and the associated Excel spreadsheet. So we're going to accept all of these. And in the add-in application, you would also get the opportunity to do what I'm going to do here, which is to, I want to save this guy as a template. And where would we find that? But the information that populates our project properties, we are not stuck with typing this stuff in. For example, we can navigate in here and maybe zoom to the bottom right corner, and I say I want the part name, and I can click on this button to capture the text. Look what happens. I can just navigate around there, and it fills in the information for me. There's OCR at work. Let's do that here for the part number. It does a pretty good job. If it doesn't do a perfect job, you can always modify it using your keyboard. And the part rev, you can window around this guy. I think you folks get the general idea. Again, any of the information that we populate the project properties with, that's information that has potential to show up in our inspection document. And while this is labeled custom properties, they are they're not SOLIDWORKS custom properties. They are metadata associated with this inspection project, associated with this this drawing document. Let's zoom back out here. And a couple other things. We'll accept that project, and I want you to notice here at the bottom we get this table, and we can start to create our bill of characteristics. In other words, our list of ballooned items. Something that you can do in the standalone as well as the add-in. I mentioned that you can have inspection items associated with the notes. So we can simply do that. We need to tell inspection that we wish to extract a note. We can simply right-click and say, what I'm going to do next is extract a note, window around the relevant text here in my graphics area. Notice we get a balloon. We get some feedback that tells us the text that it thinks it is captured, and if we like that, we just proceed on. We'll do it again here for the second note. And notice here at the bottom of the interface, I'm starting to get balloon numbers, characteristic numbers, and because these are simply notes, they show up here as the value. We're not going to get a plus, minus, tolerance, etc. I do want you to note that the columns that we see here in the bill of characteristics is the complete list of columns available to us that could propagate over to an Excel-based inspection document And you can also pare down and choose which one of these columns show up here in our user interface. Now, if we wanted to extract a dimension, it's a simple matter, again, of windowing around the relevant text in here. Notice that it recognizes that the nominal value is 325 plus or minus 20 thou. We'll do a similar one here. And a similar one here as well. We can extract GD&T symbols in the PDF world. And we do that, again, by using the OCR characteristics, windowing around this guy. And I can say, you know what? This is a profile geometric tolerancing symbol. And the value for the limits is 20 thou here. And extract that out. And even further, I could just type in the references here to A, B, and C. And notice now, for inspection characteristic item number 6, it recognizes that it's a geometric tolerance, the profile of a surface. It even puts the appropriate symbol in there because we have a GD&T font, and gives us the upper and lower limit, allowable limit, based off of that value. Again, any of the items that we work with in here, back here in item number 4, for example, I can tell them, you know, again, this is manufactured by drilling or milling or cutting. The classification for this particular item, it is a critical dimension. The method used to measure it, you can add to this list. We'll do a radius gauge. You can add any comments that you wish. You can even play with the balloons individually per characteristic. Again, the balloons are going to start life with the template specification for the characteristic. You can even change where that characteristic is attached to the numerical value. At this point, we are ready to generate an inspection report. Again, we would go through this and continue to pick out the dimensions that we want. Actually, let's see how it extracts out this limit dimension. Should do a good job. I'm just going to window around that guy. And notice it recognizes the upper and lower limit for us, and that's going to then show up in our table as well. If we're going to hand this off to somebody in our QA/QC department, we probably want to create a ballooned version of the PDF. So we can do that with one click, and we can say this is our lower plate, ballooned out, and there we get our balloon drawing. If we make some changes to our inspection regime, it's just going to cost us one button push to update this PDF. The other aspect here to go along with that PDF is we need an Excel spreadsheet. So we can go in again here, and we can specify, based off which Excel template is being used, the type of inspection document that we'd like to see. Let's run this a couple times. We'll take a look at this inspection document and export it out. And there's our dimensional test results. We have some options we can use to play with the scaling of the various items. I want you to know there's some Excel magic going on here. Again, if at 325 plus or minus, in my case, 20 thou, that seems to be grabbing the wrong one. Should be 5 thou. It's okay. We can key in some values here, and if it's 335, notice we get this nice OK item. But if I were to key in 365, little Excel magic puts the red X in the not OK column. How can we create these templates? The technique that we use, both in the standalone as well as in the add-in, is that we work within these Excel spreadsheets, these Excel spreadsheet templates. So if I take a look at this one here, for example, and I open that guy up, I'm now in Excel, and we get this little add-in to Excel, this template editor, and I can use this template editor interface to add specific tags at specific locations, and it's going to extract the information from the inspection expert regime. So I can pull in various project property tokens, the things that we typed in, the part name, the part number, the drawing name, etc. If I want them to show up in a specific cell, perhaps this isn't a great example, but if we had an example, the design record change level, maybe this is something relevant that we would type in, and I say, oh, that's a project property of, you know, additional changes or something like that. We insert that, and the appropriate tag goes in there. So if you already have Excel-based inspection sheets for particular customers or particular inspection regimes, you just save them as an Excel template and then put these appropriate tags in here. When you finish this guy up, it'll give you a chance to save it out, and then you work with it, experiment with it, and see if that's giving you the results that you want. A final item worth mentioning. I'd said that SOLIDWORKS Inspection, when in the standalone version, there is an extra, what we call professional bundle. And what the professional bundle brings to the table is the ability to key in values for those inspection characteristics right within SOLIDWORKS Inspection. And additionally, we're going to get some feedback immediately that tells us whether those values are good, marginal, or not good, using some traffic light logic. So here, if I say, you know, 20,000, or a value here of 325, notice in this measurements input section, I can key some values in. So if I say, oh, it's 345, notice that it's considered marginal because it's right on the cusp of the positive tolerance here. We can even add columns in here. For example, if we want to inspect multiple items, and the 335 goes green, 355 goes red because it's out of tolerance. And we can simply key those values in for any given one of these characteristics, and additionally create an inspection sheet that illustrates this for us. Notice also in our graphics area that some of these inspection items are taking on the colors associated with that red light, green light logic. And it's always going to show us the worst case scenario based on our project settings. You can also populate these cells with output from digital calipers. You know, they make absolute scale digital calipers that can plug into your PC via USB port, and you can simply have that at your desk measuring the individual characteristics on that piece in your hand, and you hit the send button on the calipers and it sends that value to the cells here. One last bit of functionality available in the professional version, and that is the ability to bring in data from your CMM, whether you have an optical CMM or a ferro arm or a roamer arm. SOLIDWORKS Inspection was designed with awareness of the various reports that are generated through these CMM tools. In the ferro world, it might be a CAM2 report, and inspection can bring that information in, correlate it with the dimensions or characteristics that most closely match it, and then you just tweak it a little bit to get it synchronized the way that you want it. And there we go. So what I hope I've accomplished here is to show you folks who are attending, to give you an overview of SOLIDWORKS Inspection. What I think I've successfully done is shown you how this inspection tool, whether you're working with the native SOLIDWORKS drawings or you're working with imported drawings, PDFs, or TIFFs, can dramatically change the amount of time required to generate inspection documents, which can, of course, affect your bottom line. Final time I'm going to ask this today. Are there any questions, or is there anything that you'd like me to elaborate on? And if the ideas in your head are too complex for a simple chat right now, here's my contact information. Please do not hesitate to reach out to me to have a personal conversation about SOLIDWORKS inspection. So any questions? All right. I see some questions here.
Hey,
Can
John.
a drawing be yes?
Are you ready for your question?
I am.
All right. Just wondering, can a drawing be passed back and forth between the SOLIDWORKS to standalone apps?
Absolutely. Back in SOLIDWORKS, one of the items that we saw was that we can export the balloon drawing as a PDF. Again, that's a static document, but now that you have a static PDF, you could use that in the standalone application. It will not re-balloon it for you, though. Let me think about this for a second. Yeah, you can export the characteristics from SOLIDWORKS to the standalone, but there is no live link there. It's a snapshot in time. So the answer is yes, but changes to the SOLIDWORKS document will not propagate to changes to the PDF. It's just kind of the limitation of working with PDFs as a virtual snapshot. I hope that's an adequate answer. Again, if you want me to elaborate or your question is more detailed, don't hesitate to reach out to me directly. Next question, please.
All right. Well, Greg was wondering, can standalone package use wholesale approach like add-in? Does an add-in have OCR capabilities?
The answer is no to both. So the reason why the add-in can take a wholesale approach is because SOLIDWORKS provides the API, the application programmer's interface, to anybody who wants to write to the libraries that are used in programming SOLIDWORKS. The wholesale approach is a result of the programmers leveraging the API to scan the entire SOLIDWORKS drawing. But when we say scan a drawing, it's not like an optical scan. It is a scan of the metadata, because there's tons of metadata associated with each dimension. And each dimension has a unique name in the SOLIDWORKS drawing database. So it's really the architecture that's creating some limitations to that approach. So in the standalone application, there is no facility to do a wholesale kind of OCR. The technique that I just showed you, where you basically window around the dimensions one at a time, unfortunately, computers and AI algorithms are not sophisticated enough yet to allow you to scan an entire document and realize that 75 of the 120 pieces of text are relevant dimensions. So right now, that is a limitation of the software. We take the wholesale approach with the add-in, and we take the incremental measured approach using OCR in the standalone application. I hope that was an adequate answer.
Are there any other questions out there for John? While we're waiting for any questions, I also wanted to tell you all that this webinar, as well as all of our other webinars, are recorded, and you can access them from our website at trimexsolutions.com. Upper right-hand corner there, you should see the link for our YouTube channel, as well as our Facebook and Twitter accounts as well. All right, well, it doesn't look like there's any other questions right now, so I just want to thank you all for joining us this afternoon, and have a wonderful rest of your day. Bye-bye.
Bye-bye. Thanks, everyone. Take care.